In this lesson, we're going to look at applying the cosine law. The cosine law is another tool that we can use to solve information about non-right angle triangles or non-right triangles. Let's take a look at this first investigation. It says the sine law cannot always help you determine the unknown angle measure or side lengths. Consider these triangles. So if we look at these triangles and try to use the sine law, what might happen? Well, let's first write out the sine law for this first triangle. We're looking for side Q, so we would have A over sine A equals B over sine B equals C over sine C. We're solving for a side length. We put the lowercase letters on top. Now let's substitute our information. I'm going to do it for the whole thing just to see what we have here. So for A, let's use Q. So if you want, you could actually rewrite this Q over sine Q and then R over sine R and S over sine S, just because that's going to maybe make a little bit more sense. So Q I don't know, I'll leave that there, but I know angle Q is 66 degrees. R is 3.1, but I don't know angle R. So I already have two unknowns, two sets of relationships, but there's two unknowns. And then if we take a look at S, well, there's another unknown because I know that's 3.2, but I don't know angle S. So you can see there's no pair of ratios that we can set up to solve for an unknown piece. So sine law isn't going to be useful there. Now what if I'm solving for an angle? Well, that would be a little bit different for this one. So I'm going to use the angles on top. So if I have sine E over side E, sine F over side F, and sine of angle D over side D. Let's substitute here. Angle E I don't know, so I'd be leaving it as E, but side E I know is 2.6, so there's one unknown already. If I look at F, well, I don't know angle F, but I know side F. So there again, I have two unknowns, and you're hoping that the third pair will have both pieces of information. We can see right away it's not going to. So again, sine law is going to help us here, because I don't know angle D even though I know side D. So I know none of the angles. If you don't know any of the angles, sine law is not going to help you. Okay? So there's specific givens that need to be present in order for us to use the sine law. So this is where the cosine law is going to come into play. So the cosine law can be used to determine an unknown side length or angle measure in an acute triangle. So same idea. There's three versions of the triangle depending on what you're solving for. If you're solving for side A or angle A, you use this equation. If you're solving for side B or angle B, use the second one. If you're solving for side C or angle C, use the last one. So that's how you know which version of the formula to use. Now, if your triangle's labeled with other letters, you just set the formula up accordingly for whatever you're solving for to be in that place. If you have a really careful look at this formula, you might recognize it as something else. If you look here, a squared plus b squared, or sorry, a squared equals b squared plus c squared, that kind of looks like the Pythagorean theorem. And that's exactly where this is coming from. If you were to set angle A to be 90 degrees, you would get, if you use your calculator, cos of 90 degrees is equal to 0. So what happens with your formula here is this whole piece goes away. And you'll see various versions of the Pythagorean theorem depending on what you're solving for. So that's if your angle that you're looking for is 90 degrees. So even if, let's take a look at the last one, for example. That looks mostly like the Pythagorean theorem. So if angle C was a 90-degree angle, which is what we're used to saying for the Pythagorean theorem, well, C is your hypotenuse, right? And you've got sides A and B. So you're left with a squared plus b squared equals c squared, because this would go away if angle C was 90 degrees. Okay, so you have seen this before, but because angle C is not 90 degrees, we're going to have to do something else with that last part. For your formula sheet or your toolbox or whatever you're using here, you can see here that if you're given two sides and the contained angle, meaning the angles between those two sides, you can use the cosine law. And if you're given 3 sides and no angles, then you can use the cosine law. And that's pretty much what we have up here, right? So we've got 2 sides and the contained angle. So that would have been, and here we're given 3 sides and no angle. So in both of these situations, the cosine law would have worked for us. Now it says the contained angle is the angle between the two known sides, and when using the cosine law to determine an angle, you can substitute the known values first, then solve for the unknown angle, and rearrange the formula to solve for the cosine of the unknown angle, and substitute and evaluate. Let's look at an example and see what I mean here. So here's example 1. So it says using reasoning to determine the length of a side. Determine the length of CB to the nearest meter. So CB would be here, the length between the corner points C and B. That is, if we don't want to put an X there, across from capital A, so that would be lowercase a, right? And if we label the other sides, this would be B, and this would be C. So I'm solving for side A, so I'm going to use the A formula, which said that A squared is equal to B squared plus C squared minus 2BC cosine of angle A. So write out the version of the formula that you're using first. Next, substitute any given information. Well, I'm solving for A, so I'm going to leave that. I know that side B is 32, so that would be 32 squared. Side C is 40, so that would be 40 squared minus 2 times 32 times 40 times cosine of angle A, which is 58 degrees. Now again, this is going to be a situation where you're going to want to put as much as you can into your calculator before doing the math, because, or like the rearranging and solving, because you want to have the most accurate answer possible. So what I suggest is evaluate the 32 squared and the 40 squared first. If you do that, you get that A squared is equal to 1024 plus 1600. And then if you do this 2 times 32 times 40 next, you get 2560. But that's still attached to the cos 58 degrees. So don't forget that that's all one number, this here. Okay, that's all one number, all glued together. So we can simplify this piece here, because those are considered like terms, right? They're just adding. So we can add those together. But you can't include this because it's attached to the cos 58 degrees. Okay, that's a common mistake that students make. So adding those two pieces together, we get 2624, and just rewrite the rest, 2560 cos of 58 degrees. At this point, we can punch all of this into our calculator. Okay, just remember that at the end, you're going to want to square root both sides to get rid of that squared, because we're not solving for A squared, we're just solving for A. So A is equal to whatever this is in our calculator. So how do we punch this in? So I'm going to go to second square root. It's right there. And they've opened the brackets for me already. So 2624 minus, open the bracket again so the calculator does the multiplication first, 2560 times cos of 58, and then you're going to close all of those brackets. Enter. And you should get 35.60 if we round that to 2 decimal places. So A is equal to 35.60, and this is measured in meters. So that's how we use the cosine law to solve for a side length. How do we use it to solve for an angle measure? Let's take a look at that here. The diagram to the right shows the plan for a roof with support beam DE parallel to AB. The local building code requires the angle formed at the peak of a roof to fall within the range of 70 degrees to 80 degrees, so that snow and ice will not build up. Will this plan pass the local building code? So looking at my question, first of all, looking at my diagram, I can see that this is measured in feet and inches. This is measured in feet, and this is measured in feet. And in order to do anything with this, I need all of my values to be given in the same unit. So either change them all to inches or change them all to feet. I changed them all to feet because I know that 6 inches is a half of a foot. So then this would be 19.5 feet. Okay, so that was my first step. My second step was to figure out what exactly they were asking me to solve for. So they're saying the angle formed at the peak of the roof. So that's between these two lengths here. So that would be angle B. This is what I'm solving for. And I'm solving to see if it fits that building code of between 70 degrees and 80 degrees. So solving for angle B here, let's label our triangle. So angle B, side B, angle C, side C, angle A, side A. Okay, so if I'm solving for angle B, I'm going to use the B formula that starts with B squared is equal to A squared plus C squared minus 2AC cosine of angle B. So the nice thing when we were solving for example 1 is that we were solving for side A, and side A was sitting right at the front. All we had to do was square root to get it by itself. But if you could see angle B, it's really locked in there with all this other stuff around it, right? It's right at the end. It's not something that's already set up for us. We're going to have to do some algebra to get it by itself. Let's start by substituting what we know. We know that B is 20, so I'd have 20 squared. A is 19.5, so that's squared. And then C is 10 squared. So minus 2 times 19.5 times 10, and then cos of angle B, which I don't know. So similarly to the last question, let's evaluate all the exponents first, do my multiplication, and see what we're left with. If I do that, I've got 400 is equal to 380.25 plus 100 minus 390 cosine of angle B. Combine anything I can. That would give me 480.25 minus 390 cosine of angle B. Now it's really tempting to put these together, but remember you can't because the 390 is locked in with this cosine of angle B. Okay, you can't combine those unless the 390 is by itself, which it's not. So at this point, you're doing algebra. If you want to imagine this, this is kind of like 400 is equal to 480.25 minus 390x. It's like solving that, where the x creates another variable, so we can't combine those. So in this situation, you would get rid of the 480.25 first to get the 390x by itself, and then get rid of the minus 390 to get the x by itself in the end, right? So the same thing we're doing here, we're isolating the cosine of angle B. So subtract 480.25 from both sides. You get a 0 pair, so those go away. And I've got negative 80.25 is equal to negative 390 cosine of angle B. Okay. Still want that cos B to be isolated, so let's get rid of the 390. And we can actually get rid of the negative 2 by dividing by negative 390. So these go away. Now, what am I left with? I'm left with, well, these negatives cancel each other out. So that's 80.25 over 390 is equal to cosine of angle B. Well, I don't want cosine of angle B, I want angle B. So how do I undo that? Well, I inverse cos it. So angle B is equal to cos minus 1 of all of that stuff. 80.25 divided by 390. Punch that into our calculators. We got second cos of 80.25 divided by 390. And that gives me 78.13 degrees. Oops. Yeah. 78.13 2.13 degrees. So that's how you solve for an angle using the cosine law. Now let's look back and check. We didn't actually answer the question yet. We've got the math to support our answer. It says, will this plan pass the local building code? Well, it has to be between 70 degrees and 80 degrees, and yes, it will, because that's between there. Summarize our findings with a concluding sentence at the end. The angle formed at the peak of the roof is 78 degrees. This plan will pass the local building code. All right, we have one more example in our notes here. Let's have a look. Using reasoning to determine the measure of an angle. So here's another angle question. It says, a three-pointed star is made up of an equilateral triangle and three congruent isosceles triangles. That's a lot of terminology there. Three, so we've got three of them. Congruent, congruence, math word for saying equal when we're talking about our angles on our sides. So congruent isosceles, meaning two sides are the same, two angles are the same, triangles. Determine the length of each side of equilateral triangle in this three-pointed star. So now we've got equilateral triangle saying all three are the same. Round the length to the nearest centimeter. So here's my isosceles triangle because these two lengths are the same, meaning these two angles are the same. This is an equilateral triangle saying that all three of those sides are the same, meaning all three of these angles are the same. So there's two pieces of information given to you before they even start doing anything else. So we want to know the length of these sides, these equilateral triangle sides. We know the angle measurements, but we don't know the lengths of them. So in order to find that, I've got lots of information for this triangle, so I'm going to solve for that side. So let's call that side A. So this would be angle A. And then our other sides would be B and C. Let's call this one B and this one C. So this would be angle B and angle C. Now, do I have enough information here so far? Well, let's have a look. If we set up, we've got A squared is equal to B squared plus C squared minus 2BC cosine of angle A. Let's plug in what we know. We are solving for A. B is 60, so is C. All right, well, I do have enough information here. Right? My only unknown is A. Okay? So, it says using reasoning to determine the measurement of angle, but we're actually not finding an angle, we're finding a length, so I don't know why it said that. Let's change that. Okay, so go ahead and solve. I'm going to give you a moment to do that, so hit pause on the video and go ahead and try that on your own, and then come back and check to see if you did it right. Solving for side A, you should get 20.84 centimeters is the length. So we can round that because it says round the length to the nearest centimeter. The length of each side of the equilateral triangle is 21 centimeters. So that's it for the cosine law. You can see where you can solve for a missing side or you can solve for a missing angle when you're not able to use that sine law. Thanks for joining me.